Hello everyone. For this video, I'm going to do the second exercise on the second homework assignment. Now for the second one, it wants us to enter an integer and then print all the prime numbers up to that integer, not including that integer, but up to that integer. So if I enter 20, it should return 2, 3, 5, 7, 11, 13, 17, 19, essentially all the prime numbers. So we're going to write this program. Um, let's get started. Now this one I had a little trouble doing this one, and essentially I ended up just hard coding it, and not that I hate hard coding, but I don't really like hard coding programs because I feel like it's lazy, and I don't know, I feel like it's very inefficient and it's just whatever. But for this one I had to hard code it, so this program might be wrong, but you get the same results. I've tested this program up to 1,000 and I got them all correct. So I'm guessing if you know get it right up to 1,000, you get it right up to 500 and up to so far. And I've got it right after 1,000. I'm just giving 1,000 because that's what I'm confident about. So we'll do our input. So we'll have our user input, and we'll set that to our integer. So we'll have our raw input, and we'll have enter an integer. Until we have that, we'll prompt the user for our input. And then now it's going to get hard right after the input because there's going to be a lot of assumptions that I will be making because I know they're correct, and so just bear with me. I'll try to explain them as well as I can, and so let's just go from there. So I'm going to do y equals 2 because when I'm gonna start my while loop from y is less than user input. Let me change this y to prime equals 2. This is gonna essentially be the number. I don't know why I keep saying essentially. This is gonna be the number we test to check if it's prime. Not 2, but prime. We're gonna increment prime to and then if the number is prime, it'll return us that number. And so I set it equal to 2 because 1 is not a prime number and 2 is. So we'll start at 2 because if we do 1, when we run our if statements and stuff like that, it'll return 1 when it shouldn't. So that's why I'm going to start at 2. And let's see. I'm going to divide. I'm going to divide. I'm going to divide the number. I'm going to divide our prime number by 2, so I'll name this half, and I'll do the integer of prime divided by 2.0, the floating point number. This might look contradictory because I have a floating point number and then I'm converting it to an integer. The reason for that is because I want this to be as accurate as possible while being an integer. So if I get a number like 5, if I divide that by 2, it'll give me 2, but when it comes to numbers greater than 5, I want it to be as accurate as possible, like 4.5 or 3 and stuff like that. So we'll do half equals the integer of prime divided by 2, and then we'll run our first check. We'll do our first check. We'll do if our prime number and the divisor of half if that equals 0, then I want it to check if that half equals 1. And I do this because of this number too. When you divide 2 by 2, or take half of 2, you'll get 1. And so that's going to cause problems because then it won't return 2 because it is divisible by half of itself, but it's not. But half of itself is 1, which is one of the numbers that are included for prime numbers to be divided by. So that's what we're doing here. We're dividing it by 100 or by 0 or by half. We're checking the remainder. And if there's no remainder, then I want to check to see if it's because that half is 1. And if it is, that means that it's checking for 2, and then it'll print that prime number, and I'll put a comma after it because the assignment also asks us to print it vertically. I'm gonna be stumbling and mumbling around this program because it really confused me, but I was able to get it. Yeah, I guess I was able to get it. So, and I'm a little disappointed in the program that I ended up producing, but it works and it's as good as I could manage it to be, so bear with me. So that's what we'll do. And now we'll do after this if statement. So let's assume that the remainder isn't 1, and it's something like, or let's say half of it isn't 1, and it's something like 3, which would be half of 6, or 4, which would be half of 8, and stuff like that. So we'll do an elif. We'll do an elif. Let's say elif oh, we'll do an else actually. Else. Let's see what happens if we do this. Yeah, okay. Okay, I tried it'll just keep printing 2 without incrementing it. Yeah, that's what I'm gonna be doing. And then we'll do prime plus equals 1. So that's why. Okay, so now it's just gonna give us even number. Oh, give us this. Let me see. I'm not gonna mess around too long. So 2, 3, 4. Okay, well. Okay, so we'll get out of this. I'm gonna do an elif out here. And this time this is another given that I'm gonna have to force here. I'm gonna take the square root of a number. So this is gonna be the integer of y, and the square root formula that I'm gonna use here is times 1/2, or to the power of 1/2. I'm gonna use a floating point again and convert it to an integer to make it as accurate as possible, because for the prime numbers we don't want us to give us floating points, and so I'm trying not to leave any either. So I'm taking the square root of, oh, this should be prime actually, of the number that we're checking, and then we're gonna run it against this. So we're gonna do that. So that way if we get numbers like 9, or if we get squares, we'll make sure that those don't leave that those aren't included in our prime numbers. So we'll do our elif. Let's start with if prime and then half does not equal 0, and we'll do an and prime divisor of its square root does not equal 0. You want it to print that prime number. So let's see what we get here. One through 20. I keep forgetting to increment prime. So we'll do prime plus equals 1. So let's do that. There we are. So this kind of works. Let's try bigger numbers. Let's try 30. And here's where we'll face the problems. 27, 21, 15 is not on here. I'm not gonna care why. So we're gonna, let's see. Let's add a check. Let's see. And prime divisor of 3 does not equal. This is where the hard coding begins that I just can't stand. Is now we're doing this here, which I don't like to do, but I guess it'll become essential. So let's do 30. Oops, not that. Okay, so it gets up to 29. Let's see. If I do something like 50, I don't think we see any problems. Let's see. If I want to do something like 100, here we go. 55 and 77 and then 85. Okay, so yeah, I see. Now we're gonna do more hard coding. So now we'll do another AND prime mod of 5 and, or I keep saying mod, it's divisor of 7. I gotta make sure state these do not equal 0. Same thing here. 0. Let's try that. So I'll do 100 this time. And we're gonna face issues because now we're gonna miss numbers like 5 and 7 here. But perhaps we have it solved. So there's gonna be, here we go. Now we have to include numbers like 5 and 7, which you can't do because they're knocked out by this. So now I'm gonna do a prior. So elif prime equals 5, print prime, and then another one, elif prime equals 7, print prime. And now this way we'll have them back included. Am I having, let me see, let me try something. So now if we do smaller numbers like 5, we'll get 2 and 3, stuff like that. So it works. I'm looking for something. I could like, you know, use Wikipedia and find out these are correct. I guess you guys could do that and check it for me. But just for 6, because I had it on mine, I included 9. I can't find it there, why, but I had it in there. I included 9, so it shouldn't change anything. Let me see. So what number was I worried about? Like 127. Okay, so yeah, it didn't really change much, but just to lump another one in here. So this is basically, this is what we did. As you can see, what my problem was is that there was a lot of hard coding, like 5 and 7, and then these right here. You know, it's not exactly, you know, programming. We're just lumping numbers in here. So we prompt the user for an input for an integer, and then we start prime number 2 because 1 is not prime. So we start at 2,